We are now on Module 10, Scalability and Load Balancing. In this section, we will discuss DRS, the Distributed Resource Scheduler. And we will see that DRS is one of the most advanced features of vSphere. And when they call vSphere agile, they're referring to DRS. In this section, we will look at load balancing across ESXi hosts. We will do a review of vMotion, and we'll see that DRS is simply automated vMotion. We will set up and configure DRS, we will examine the load distribution, and we will configure affinity rules. Let's start out with what is a cluster. What is a cluster? A cluster is a group of hosts. Clusters enable the vSphere high availability and distributed resource scheduler solutions. If we click on Learn More about clusters, we can see that we can use clusters to maximize host utilization. In a previous section, we looked at vSphere high availability. In this section, we will look at DRS, the Distributed Resource Scheduler, and we will see that DRS continuously balances virtual machine workloads across your ESXi hosts. When virtual machine activity requires more CPU or memory resources than the host it is running on can provide, then vCenter server triggers vMotion migrations to balance the workload. In other words, DRS moves virtual machines from busy ESXi hosts to less busy ESXi hosts. DRS is really just vMotion automated. So let's do a review of vMotion. As you recall, from a previous chapter, we saw that vMotion allows us to move a running virtual machine from one ESXi host to the other for the purposes of load balancing. So let's look at an example of using vMotion to perform load balancing. In this example, we have one ESXi host which is running at 100%, and two more ESXi hosts that are each running at 25%. This is called an unbalanced cluster. So what we can do is we can move some of the virtual machines from the more busy ESXi host and move them to the less busy ESXi hosts. And now you can see all three ESXi hosts are running at 50% utilization, and this is called a balanced cluster. You can manually perform load balancing by using vMotion to move virtual machines from less busy ESXi hosts to more busy ESXi hosts. Or you can automate the procedure using DRS. DRS automates vMotion and automatically moves virtual machines from more busy ESXi hosts to less busy ESXi hosts. So let's set up DRS. We can either create a new cluster or enable DRS on an existing cluster. To create a new cluster, I would go to my data center, right-click, select New Cluster, and type in the name of that cluster, such as Cluster 2. Then I would select the DRS checkbox and check off on the DRS checkbox. And then I could set the automation level to fully automated. That is the way to create a new DRS cluster. Or what I could do is enable DRS on an existing cluster. We already have a cluster that we made in a previous section called Cluster 1, and we can see that DRS is currently not enabled for Cluster 1. So to enable DRS, we click on Edit. Then we click off on the checkbox that says Turn on vSphere DRS, and then we select DRS Automation and we expand that entry. Under DRS automation levels, we could select fully automated, partially automated, or manual. Manual means that DRS will not move virtual machines. It will provide recommendations, but you have to move them yourself. If we select partially automated, then DRS, when a virtual machine starts up, DRS will place the virtual machine on the least busy ESXi host, but it won't move it after that. But if we select fully automated, then DRS, if we select fully automated, whenever DRS detects that one ESXi host is grossly overloaded, then it will automatically move those virtual machines from the overloaded ESXi host to a less busy ESXi host. This is the fully automated method, and that's the one we would like to use. Now the question is, when does it move virtual machines from one ESXi host to the other? And this takes us to the migration threshold. We can set migration to be conservative. If we set the migration threshold to be conservative, that is to say, we set it to 1, that means it's not going to move virtual machines. It will only move virtual machines if virtual machines have to be moved, such as when an ESXi host is put into maintenance mode. We can select a migration threshold level of 2, and then DRS will move virtual machines only if a significant improvement can be achieved in the cluster's load balance. We could select the migration threshold to 3, and then it would move virtual machines even if that only produced good improvements in the cluster's load balance. If we set the migration threshold to 4, then DRS will move virtual machines even if that only provides a moderate improvement in the cluster's load balance. And if we set it to aggressive, it will vMotion virtual machines even if that only provides a slight improvement in the cluster's load balance. And often we don't want to select aggressive because what it will do is move virtual machines even if that only achieves a slight increase in the load balance. So let's say one ESXi host is running at 70% and the other ESXi host is running at 75%. In that situation, if we set the migration threshold to 5 to aggressive, then it will move virtual machines even though the cluster is not that far out of balance. And the problem with this is we can start moving virtual machines to the point where the CPU utilization taken up by the movement of virtual machines is greater than the CPU utilization which is saved. Therefore, we like to set the migration threshold to 2, and that way virtual machine migrations will occur only if they provide a significant improvement to the cluster's load balance. Virtual machines will only be moved if one ESXi host is grossly overloaded and another is grossly underloaded. That's the migration threshold. Now, if we look at power management, if we enable power management, then what that will do is that if one ESXi host is running at very low CPU utilization, then what vSphere DRS will do is move any virtual machines off that ESXi host, and then will shut down that ESXi host to save power. This is called power management. If I click on OK, I can now see that DRS is turned on, that the automation level is set to fully automated, and power management is set to automatic. So if there are any ESXi hosts which are not busy at all, then DRS can shut those ESXi hosts down to save power and turn them back on when the CPU utilization is needed. Now let's do a before and after shot. If we examine load distribution before DRS is installed, we can see that there is a load imbalance. If we monitor this cluster, we can see that for the whole cluster, CPU utilization isn't that high and memory utilization isn't that high. However, if we look at summary and we look at the vSphere DRS status, we can see that this is a grossly imbalanced cluster. So, and furthermore, if we look under the monitoring tab for CPU utilization, we can see that one ESXi host is totally maxed out at 100%, whereas the other ESXi hosts are only running at 5 to 10% utilization. This is called a very imbalanced cluster. Now, let's look at load distribution after DRS is installed, and this is an example of a balanced cluster. If we go to our cluster for summary information and we look at the DRS status, we can see that this is a nearly perfectly balanced cluster. So we can see that DRS, the Distributed Resource Scheduler, performs load balancing. It automatically moves virtual machines from more busy ESXi hosts to less busy ESXi hosts. And this concludes our introduction to DRS.